Hello class 7 students, welcome back to the Science Digital class. Today we are going to start chapter 6 of our textbook, which is Heat and Temperature. Chapter at a glance. Heat, temperature, thermometer, transfer of, engage. Identify the mode of heat transfer shown in the following picture. तो इन पिक्चर्स में किस मोड से हीट का ट्रांसफर हो रहा है ये आपको अपने आप पता लगाना है एंड यहाँ पर लिखना है. Heat. In winters, we feel warm when we rub our palms continuously. Heat is produced due to the loss of the kinetic energy of the hands. When you hammer the nail, the heat of the nail gets heated up. The head of the nail gets heated up, which causes the sensation of hot and cold is called heat. When a body is heated, its energy increases, and when it is cooled, its energy decreases. Heat is measured by the change in temperature it produces in materialistic body. Unit of heat. There are two types of units of heat. Non-SI unit, calorie, kilocalorie. These are older units of heat. SI unit, joule. This is the presently used standard unit of heat. तो हम हीट का पता लगाते हैं चेंज इन टेम्परेचर से. और हीट की दो टाइप की यूनिट होती हैं. एक स्टैंडर्ड यूनिट जो कि जूल है और पुरानी यूनिट जिसको हम पुराने टाइम पे यूज करते थे जो कि कैलोरी और किलो कैलोरी है. तो हीट को हम अलग अलग तरीकों से लॉस ऑफ एनर्जी को भी हीट का लॉस कह सकते हैं और गेन ऑफ एनर्जी को भी हीट का गेन कह सकते हैं. नाउ लेट्स अंडरस्टैंड कि किस तरह से कैलोरी, किलो कैलोरी, जूल में कैसा रिलेशनशिप होता है. लेट्स सी रिलेशनशिप्स. 1 kilojoule is equals to 1000 joules. 1 kilojoule is equals to 1000 joules and 1 kilocalorie is equals to 1000 calories. So 1 calorie is equals to 4.184 joule. 1 kilocalorie is equals to 1000 calorie. So 1000 calorie into 4.1484 joule. So 1 kilocalorie is equals to 4184 joule. Temperature. While watching the weather bulletin, we often hear about the temperatures of different places. The quantity temperature is a reliable method of finding out how hot or cold a body is. It is a measure of the degrees of hotness or coldness of a body. The different units used for measuring temperature are degree Celsius, degree Fahrenheit, and Kelvin. Here we will be using only degree Celsius or degree Fahrenheit. The following formula shows the relationship between degree Celsius और degree Fahrenheit. तो इस फॉर्मूला से हम पता लगा सकते हैं कि कितने डिग्री में कितने फ़ारेनहाइट्स होते हैं और कितने फ़ारेनहाइट्स में कितने डिग्री सेल्सियस होता है. C/5 where C is for Celsius is equals to F-32/9. You can use the above formula to convert temperature from one unit to another. Temperature scales. अब temperature के लिए कौन कौन से scales होते हैं? Let's see. These are Celsius scale, earlier called a centigrade scale, Fahrenheit scale, Kelvin or absolute scale. In common use, temperature is measured on the Celsius scale. Therefore, we will describe only Celsius scale. तो हम हमेशा ज़्यादातर केसेस में सेल्सियस स्केल का यूज करते हैं टेम्परेचर को नापने के लिए. इसलिए यहाँ पर हमने सेल्सियस स्केल को डिस्क्राइब किया है. The Celsius scale temperature was designed by Henry Celsius 1701 to 1774. On this scale, temperature is described in degrees Celsius. It is a metric scale of temperature. In this type of scale, we consider lower fixed point and upper fixed point. This is the picture of Henry Celsius, and this is a kind of thermometer which is used for temperature measurement. Lower fixed points the temperature at which pure water freezes at sea level to be 0 degree Celsius. तो लोअर टेम्परेचर जो हमने फिक्स किया अपने स्केल पर, अपनी सेल्सियस स्केल पर, वो टेम्परेचर था जिस टेम्परेचर पर वाटर फ्रीज हो जाता है. The temperature at which pure water boils at sea level is called the upper fixed point. और हमने अपर फिक्स्ड पॉइंट लिया वो टेम्परेचर जिस टेम्परेचर पे वाटर बॉयल होने लगता है. It is taken as 100 degree Celsius. Divide the gap between them into 100 equal part. Each part is equal to 1 degree. और उनके बीच में हर पार्ट को डिवाइड किया 1 डिग्री में. Thermometers. To measure the temperature of an object, we use a device called thermometer. There are different kinds of thermometers. However, the most commonly used thermometers are mercury thermometers used in laboratories and by doctors. तो thermometers वो devices होते हैं जिनकी help से हम temperature को measure करते हैं और most common जो thermometers use होते हैं वो mercury thermometers होते हैं. Types of thermometers. First, the laboratory thermometer. A mercury thermometer commonly used in a laboratory shown alongside. It consists of a thick-walled fine-bore glass capillary tube. This capillary tube has a small thin bulb at its lower end. This bulb and a small portion of the capillary tube are filled with pure and dry mercury. The air in the portion of the tube above mercury is removed by evacuation and the upper end of the tube is then sealed. The portion of the capillary tube above the bulb, commonly called stem, is graduated in degrees, usually from -10 degrees Celsius to 110 degrees Celsius. Such a thermometer can be safely used for measuring temperatures between 0 degrees Celsius and 100 degrees Celsius. Thus, the range of laboratory thermometer is taken as 0 to 100 degrees Celsius. On the Celsius scale, 0 degrees Celsius is the temperature of the melting ice and 100 degrees Celsius is the temperature of the steam under normal pressure conditions. Knowledge basket. Except for the doctor's thermometer, which is also a mercury thermometer, all thermometers are read keeping the mercury bulb in contact with the body whose temperatures is to be measured. How to use a laboratory thermometer? Before you start using a laboratory thermometer, we will give you a few tips to use it correctly. Follow the instructions for the proper use of a laboratory thermometer. Observe the calibration on the stem of thermometer. Find out the value of one small division of the thermometer scale. It may be 1 degree Celsius or 0.5 degrees Celsius. Now suspend the thermometer from a stand with the help of a hook. Place a 100 milliliter beaker just below the thermometer. Pour tap water onto the beaker such that the bulb of thermometer is completely dipped into the water. Observe the mercury thread in the thermometer. Read the temperature when it becomes constant. Record it in your notebook. While reading temperature on the thermometer, your eye should be at the level of mercury. Report your temperature as follows. Result: temperature of tap water is equals to dash degrees Celsius, whatever you have got observed. Precautions to be observed while using a laboratory thermometer. While the temperature is being taken, the bulb of the thermometer should be kept vertical and in contact with the object whose temperature is to be measured. It should not touch the bottom or the sides of the container. The reading of temperature should be taken without removing the thermometer from its position. The eye of the observer and the mercury in the capillary tube should be at same level. The thermometer should not be used to measure temperatures below its lowest marking or above its highest marking. Clinical thermometer. It is smaller in size with a temperature range from 35 degrees Celsius to 42 degrees Celsius. The corresponding marking in degree Fahrenheit are also usually marked on it. These thermometers are used for measuring human body temperature. The normal human body temperature is about 98.6 degree Fahrenheit. These thermometers have a kind or slight bend just above the bulb of the thermometer so as to stop the mercury from coming back into the bulb after the thermometer has been removed from the contact with the. A clinical thermometer consists of a narrow glass capillary. It has a bulb at one end and is sealed at the other end. As temperature rises, the mercury expands and moves up to show the temperature against the printed scale. How to use clinical thermometer? Before using thermometer, should be washed preferably with an antiseptic solution and dried using a cotton swab. Hold the thermometer firmly and give it a few jerks. The jerks will bring the level of mercury below 35 degrees Celsius. Now place the bulb of the thermometer under your tongue for about 2 minutes. Take the chosen scale is called its temperature. Temperature of an object is measured with an instrument called thermometer. Precautions while reading a chemical thermometer. Wash the thermometer before and after use. Handle the thermometer with care to prevent breakage. Hold the thermometer horizontally parallel to the floor at the eye level. Make sure the mercury level is below 35 degrees Celsius before use. Do not touch the bulb of the thermometer while reading it. Difference between clinical and laboratory thermometer. Clinical thermometer, it is smaller in size. Laboratory thermometer is larger in size. Clinical thermometer, the range of temperature in clinical thermometer allowed to be measured is 35 degrees Celsius to 42 degrees Celsius. The range of temperature in laboratory thermometer is allowed to be measured is generally minus 10 degrees Celsius to 110 degrees Celsius. In clinical thermometer, there is a constriction which does not allow mercury column to fall on its own. There is no such constriction in laboratory thermometer, so the mercury level falls as soon as it is taken out of the substance whose temperature is to be measured. One needs to give 5 jerks to the thermometer so that mercury level fall and is ready for the next use. The mercury level falls to the room temperature on its own in laboratory thermometer. Similarities between a laboratory thermometer and a clinical thermometer. Property: thermometric liquid. Laboratory thermometer, mercury. Clinical thermometer, mercury. Scale of temperature: laboratory thermometer, Celsius. Clinical thermometer, Celsius. Tech talk. Scientists have created tiny thermometers called nanothermometers that use special properties of extremely small diamond particles to accurately measure temperatures. Atoms of other elements are added to the diamond particles such that the particles glow when a laser falls on them. The properties of the glow depend on temperatures around the diamond particles. These nanothermometers can be used to observe temperature changes caused by the activities in cells of the body and in microorganisms. In the future, this technology may be used in medical research to study the activity of cancer cells and understand how to treat cancer at the cellular levels. Transfer of heat. Heat flows from a body at higher temperature to a body at lower temperatures. This flow occurs until both bodies have equal temperature. There are 3 different ways in which heat can be transferred from a body to another. These are conduction, convection, radiation. तो हमेशा 2 बॉडीज के बीच में हीट ट्रांसफर तब होता है जब एक बॉडी में हीट कम हो और एक में ज्यादा. तो ऐसे टाइम पर 3 तरीके से हीट का ट्रांसफर हो सकता है: कंडक्शन, कन्वेक्शन या फिर रेडिएशन. लेट्स फर्स्ट स्टार्ट विद कंडक्शन. कंडक्शन क्या होता है? कंडक्शन इज द प्रोसेस इन विच ट्रांसफर ऑफ हीट इज पॉसिबल through molecule to molecule from the hot to the cold end. The molecules themselves do not travel from one end to the other. The process of transmission of heat energy in solids without the actual movement of particular molecules from their position is called conduction. तो कंडक्शन में मॉलिक्यूल्स खुद ट्रांसफर नहीं होते, मॉलिक्यूल्स अपने पास वाले मॉलिक्यूल को हीट ट्रांसफर करते हैं और फिर वो अपने पास वाले को, और इस तरह से कंडक्शन होता है. एक्सप्लेनेशन ऑफ कंडक्शन. Explanation of conduction. In solids, the constituent particles are very closely packed. They can only vibrate about their mean position. When one end of a metallic strip or rod is heated, the particles at that end absorb energy and start vibrating more rapidly. These rapidly vibrating particles collide with their neighbors and transfer a part of heat energy to them. As a result, these particles also start vibrating more rapidly and in turn cause their neighbor to vibrate more rapidly. This process continues until the last particle also start vibrating more rapidly. Thus, heat energy is transferred from one particle to particle through the whole length of the strip or rod. The process of conduction may be considered similar to the passing of a book from person to person in a classroom. Condition for the conduction of heat. Heat can be conducted from one body to another if they are. तो कंडक्शन तभी पॉसिबल हो सकता है जब 2 बॉडीज हैं. फर्स्ट, वो दोनों कांटेक्ट में हो आपस में एक दूसरे के, और दूसरी कंडीशन ये है कि दोनों का टेम्परेचर अलग अलग हो. तो फर्स्ट, इन कांटेक्ट विथ ईच अदर. सेकेंड, एट डिफरेंट टेम्परेचर्स. गुड एंड बैड कंडक्टर्स ऑफ हीट. Materials which contact heat rapidly are called good conduction of heat, and materials which do not conduct heat rapidly are bad conductors or insulators of heat. All metals and their alloys are good conductors of heat. For example, copper, iron, brass, steel, silver, etc. are good conductors of heat. Glass, air, plastic, rubber, etc. are insulators Most liquids are poor conductors of heat. जो भी हीट के गुड कंडक्टर्स होते हैं उनके थ्रू हीट इजीली पास ऑन हो सकती है और जो भी बैड कंडक्टर्स होते हैं हीट के उनके थ्रू हीट पास ऑन नहीं होती, जैसे कि ग्लास, रबर, पेपर एटसेट्रा. नाउ अब इनके एप्लीकेशंस. यूज ऑफ गुड कंडक्टर्स. गुड कंडक्टर्स के क्या क्या यूजेस होते हैं? गुड कंडक्टर्स हैव देयर वाइड यूजेस. First, cooking utensils are usually made of metals like copper and aluminium and alloys like brass and stainless steel because they are good conductors of heat. Number 2, boilers are often made with copper because copper is a good conductor of heat. Number 3, being a good conductor of heat, mercury is used as thermometric liquid. Number 4, cooling. Cooling coils of refrigerators and air conditioners are made of copper as they easily conduct away the heat. Copper tubing is used in automobile radiators as they readily takes heat from hot water coming from the side of engine. Uses of bad conductors. Like good conductors, bad conductors are also very useful in our daily life. Number 1, the bottles, saucepans are provided with wooden or ebonite handles. As wood and ebonite are poor conductors of heat, we can hold them when the objects are hot. Number 2, woolen clothes are comfortable in winter season. Woolen clothes have fine pores which are filled with air. Air and wool, being poor conductors of heat, protect the body from losing heat to the colder surroundings. Number 3, sawdust, being bad conductor of heat, is used to cover ice blocks and prevent them from melting quickly. Number 4, a new quilt is warmer than the old one because the new quilt contains more air pockets, so it entraps more air and hence is a better insulator. Number 5, ice boxes, refrigerators have inner linings of glass wood, which is very poor conductor of heat. This greatly minimizes the chance of outside heat passing into them. Number 6, birds puff up their feathers in winter because in doing so they trap a large amount of air which in turn act as an insulator and does not allow the heat to flow out from their bodies. Number 2 जो heat transfer का method होता है वो होता है convection. Now let's know about it. It is a mode of heat transfer among fluids. When a fluid, whether a liquid or a gas is heated, its particle gain thermal energy, heat, which increases their kinetic energy. The increased kinetic energy increases the frequency of collision among the particles. Every time the particles collide, they transfer the heat energy and the fluid becomes less denser and increases volume. The fluid, after being less denser as lighter, rises up to be replaced by the cold, heavier fluid. This cyclic movement of water during heating is called convection current. Air too is not a good conductor of heat. Being a gas, it can flow and spread fast and transfer heat by convection. Practical application of convection current. Ventilators. Rooms are provided with ventilators and exhaust fans near top of side walls. The air we breathe out is warmer and hence lighter than ordinary air. It moves up in the room and escapes through the ventilators or exhaust fans. The fresh air enters the room through the windows and doors. It is cooler and takes the place of the warm air rising upwards, and thus a convection current is set up. Land and sea breezes. Land and sea breeze near the coastal areas are a result of the convectional current set up in air. Since land surface is better conductor of heat than water, it gets heated faster during the day. This makes the air close to the land surface warmer. The warmer air rises up and the cool air from the sea rushes to take its place. This gives the rise to the sea breeze. At night, the land cools faster than water in the sea. So the air above the sea is warmer than the air over the land surface. The warmer air over the sea, being lighter, rises up and cool air from the land takes its place. This gives rise to land breeze. Ocean currents. The ocean currents near the equator is heated by the sun to a much higher temperature than the water near the poles of the earth. This is because the sun rays fall almost normally in the equatorial region but slantingly in the polar region. The ocean water in the equatorial region expands and becomes lighter, but the water in the polar region remains cold and heavy. Therefore, the convection current of warm water flow on the surface of ocean from equator towards the poles. Below the surface of the ocean, currents of cold water flow from the poles towards the equator. These currents are called ocean currents. नंबर थर्ड मेथड जो है हीट ट्रांसफर का वो होता है रेडिएशन. Direct transfer of heat from a hot body to a cold body having no contact between them and without the help of any medium is called radiation. तो रेडिएशन में दो बॉडीज के बीच में हीट ट्रांसफर होती है जब उनके बीच में ना तो कोई कांटेक्ट होता है और ना उन्हें किसी मीडियम की जरूरत होती है. In conduction and convection, heat is transmitted by the particle in the medium, but in radiation there is no need of medium particles. All the hot objects, whether they are solid, liquid or gases, can transfer heat by radiation, can occur even in vacuum. For example, heat is transmitted from sun to earth by the radiation. The sun radiated heat and this heat is called radiant heat. The amount of heat radiated by a hot body depends on its temperature, its color and nature, dull or shiny. Absorption of radiant heat. The quantity of heat absorbed by a body depends on its distance from the source of heat. A body closer to the source receives more heat than one farther from the source. That is the reason that inner planets are more warmer than the outer planets. Black bodies are better heat absorbers than the white bodies, as well as black bodies are better heat radiators than the white bodies. A brightly shining surface is poor absorber of heat radiations because it affects the radiation falling on it. Differences between conduction, convection and radiation. Conduction. The transfer of heat takes place without the actual movement of molecules, they merely vibrate in their fixed position. Convection. The transfer of heat takes place with the actual movement of molecules. Radiation. The transfer of heat takes place through waves, no movement of molecules is involved. Conduction. Heat is transferred between two solid objects in contact with each other. Convection. Heat is transferred within a liquid or a gas. Radiation. Heat is transferred without any medium and can take place even in vacuum. Conduction. It is generally a slow process. Convection. It is generally faster than conduction. Radiation. This is the fastest mode of transfer of heat. Now let's see a working of a thermos flask. A thermos flask is used to store a substance and maintain its temperature such that it remains hot or cold for a long time. A thermos flask consists of a double-walled container made of a glass or a stainless steel. Both the walls are polished so that they are shiny. They prevent heat back into the flask. The space between the walls is a vacuum. This prevents heat loss through convection. There is no air molecules to carry out the transfer of heat. The mouth of the flask is closed with either a plastic cap or a metallic cap. The glass bottle is placed in a metal or a plastic outer casing that prevents the loss of heat. Through conduction, corks or other insulating material support the glass bottle within the casing. The substance within the flask thus maintains its temperature for a long time. This is the structure of a thermos flask. Moral learned. Heat and temperature are important concepts for each of us every day. How we dress in the morning depends on whether the day is hot or cold. The most of what we do requires energy that ultimately comes from the sun without heat. All plants would die and eventually animals that rely on plants are food, including humans, would die. Recapitulation. An invisible energy which causes the sensation of hot and cold is called heat. To measure the temperature of an object, we use a device called thermometer. Heat flows from a body at higher temperature to a body at lower temperature. Conduction is the process in which transfer of heat is possible through molecule from a hot to the cold end. The direct transfer of heat from a hot body to a cold body having no contact between them is called radiation. Thank you class. Let's meet again in the next class.